name is Jordan Hibben.
I'm Armand Villani.
I'm Alex Devonport.
And I'm James Bradshaw. And our project is wireless power transmission. And so far we've seen consumer solutions to this problem, such as inductive coupling solutions, such as toothbrushes and Qi wireless chargers. But these are near-field connections that still require the devices to be almost touching each other. And this has been extended to a couple inches in the case of plugless power, who have implemented it for their electric vehicles. It has been extended even further with Ritricity and their use of inductive, highly resonant RLC circuits. But we intend to use the infrared spectrum for our implementation. But for more technical details, I'm going to pass it over to my friend Alex here.
So, I'm the circuit design and programming lead for our project. My job is to figure out how the wireless charging system will know where the thing that needs to be charged is located, and how to steer that power in the direction that it needs to go. Our plan so far is to use active RFID location and what's known as a phased array antenna to steer the power. I'll be working on the location and phase control for the system. There are plenty of challenges to overcome even in this part of the project. Foremost, we need to find the happy medium between performance and part density. For example, we'd like to control the phased array antenna with, ideally arbitrary precision, but the amount of components that you would need for that goes up very quickly. And that's, just problems with the circuit. Armand will be handling the antennas.
Right, so as Alex alluded to, I will be handling the antennas. I'm the antenna lead for our project. And as my friend James said, most of the situations in the current means of doing this sort of thing are near field, kind of mid-range. We're looking for a radiative solution, something where we can actually direct a microwave beam and low microwave frequencies, nothing dangerous of course, to power user devices. To do that, we're going to be using a phased plane array, like Alex mentioned. And right now we're looking at circular arrays, reason being that we think it'll be a lot easier to fabricate our feed network for a circular array as opposed to something that's your typical planar kind of square blocks of antennas. So moving forward, what we need to do is just kind of weigh the pros and cons of that, look at costs of elements, different parts like Alex was saying, look at what kind of configuration, how many elements gives us the best directivity to aim this beam towards our devices, and move forward, get a solid design down, get dimensions for what we're going to be building, and then simulate that in some kind of software to really make sure that this is the best thing we can do. Moving forward, I will hand you off to Jordan Hibben, who's going to explain our scheduling.
So far, a majority of all of our focus has been in research and looking up patents and other technologies to compare to our idea. Currently, the planning for the project, we're anticipating the designing and sort of circuit design of this project to be done in early November. The reason it's pushed out a little bit far like that is because a lot of the individual components that go into this project rely on the previous component to build the next one. So because they kind of chain together, it takes longer because you have to complete one before you can start the other. So moving forward, once we get past the research phase, we'll finalize our design and move forward from there.